Finding the inverse of a domain-restricted function. If a function fails the horizontal line test, then we may restrict the domain of the function so that it passes the horizontal line test, and then we could find an inverse function. So this is the one we looked at earlier to find the inverse of f of x equals x squared, just that part. And that part we said, no, that's a parabola and it fails the horizontal line test. But if we restrict and say that x has to be greater than 0, then x greater than 0 is over here. We're only looking at half of the parabola, not the whole picture. And if we only had half, then we could draw a horizontal line test, and so we would be able to find an inverse. And let's go through the steps to find the inverse. So remember, we would make f of x, this is y, equals x squared, and we're going to reverse x and y. So this will be x, this will be y. Also, we have to reverse here. So we're going to have y greater than 0. Now we're going to isolate the y. So this is where you would do your square root. So plus or minus the square root of x equals y. But notice we have this restriction now on y, which says y has to be greater than 0, which means y has to be the positive choice, since it has to be greater than 0. And so we will just have the positive square root, and if you don't write plus and minus, it is the positive square root of x equals y. Or we can rewrite with inverse notation. I want to put these into our graphing calculator so that we can verify the graph flips across the line y equals x, and also we can look at the table and see that the x's and the y's switch. So the range and the domain switch. So we'll go under y equals, and you might remember from piecewise functions how to restrict the domain with a divide and then this piece in parentheses. So f of x equals x squared, x to the second. I'm going to restrict the domain, so I use divide, and then in parentheses I put the condition. So x, and remember it's under the test button, so you're going to do second and math to get to the logic symbols, and you want greater than. So number 3 is greater than 0. Close your parentheses, and I can tell it to graph. So I should only get this half. That's what I'm getting. Now I'm going to go back in there, and I'll go down to my next one, and I'm going to graph square root of x. And I took care of the y greater than 0 just by choosing the positive one. And we'll graph that. And now I'm going to put the line y equals x in there so you can see that it flips across. So you have a mirror image across that line. Now let's have a quick look at the table. And so here you are out of the domain, because on this x and y1 is for your first function that we entered, and 0 was not allowed. X had to be greater than 0, so that's why you're getting an error there. So it was something not in the domain. Let's look at some other values in the table. Remember, the x's and the y's are supposed to switch. So 1, 1 gives you the same, but here I have 2, 4. So I should have 4 and 2. Here I have 3 and 9. So for x equals 9 in the first column, I should have 3 in my y2. And I do. So those switch. For our next problem, f of x equals x squared minus 6, and our restriction is x is greater than or equal to 0. So first they ask us to find the inverse. So we will rewrite as y equals x squared minus 6. Then we will switch the x's and y's. We will solve for y. So we're going to add 6. And then we'll take the square root of both sides. And then we'll go with our restriction. For y to be greater than 0, we're going to need the positive square root. So we're going to have this one. And we can write it with our inverse notation. Now let's go into our calculator. And so we'll do y equals x squared minus 6 and we're putting a condition, so divided by and put it in parentheses, x, and then go under second math. That way you're under test. This time you want greater than or equal to, which is number 4, and 0. And then remember to close your parentheses. I'm going to hit enter. All right, I'm going to put my inverse function in, square root of x plus 6. You have to close your parentheses there. Right, and I'm going to go ahead and put in the line y equals x. And we'll choose graph. I'm going to slide this over a tiny bit now. So I have my conditions in. And there you go. You might have worried a little bit here. You know, you do have restrictions on this, but it's taken into account automatically. Your x cannot be less than negative 6 because your radicand has to be greater than or equal to 0. So you did not have to enter that. So let's look at the table. And if we put a negative 1 in for x, and this is with the first one. This first column is with the first one. If we put a negative 1 in, this says x has to be greater than or equal to 0, so I could not put a negative 1 in. I could put a 0 this time. So if I have 1 here, I get a negative 5. So let's see about a negative 5 gives me the 1 with the new picture. It wasn't allowed in this picture, but it is allowed. Just trying to show you some, right? 0 and negative 6, so negative 6 down here should go with 0, which it does. So your range and domain have switched, and let's look for one more. So 2 goes with negative 2. So a negative 2 here goes with 2. Let's look at part C. They ask us to give the domain and the range of f inverse. And the f inverse is our square root function here. So domain from the picture, it starts at -6 and it goes forever to the right. That is coming from this. Your x plus 6 has to be greater than or equal to 0 if you're doing algebra. So x has to be greater than or equal to -6. And let's pull our calculator back up and see. All right, and so here is our x. And so that is -6, and it goes forever to the right. For our range, the lowest this one goes is 0. Notice back we made our restriction here when we switched the restrictions. This goes with our new function. The y has to be greater than or equal to 0. Sorry. Right? And it is. This function does not go below. This is the original, and I can take it off of there. If I go back under y equals, right, I can take off the original one. And if you don't want to take them off, you can turn off these cursors. So I can go back on that one and just click enter. And now it will be still. I only want to show the square root, and I'll make this one be still. And I'm going to click graph again. So if you're entering something a few times, you can use that little trick to just turn the cursor off and it'll save it, but it will not show it on your picture. And so my range is my height. And remember, as the square root function goes out, it climbs. It's slow, but it goes up forever. All right, and our range, we said the lowest point is 0, and that also comes from here, and I'll pull the graph back up in a minute. Right, so it can equal 0, and it goes forever up. And I'll pull the calculator back up. It doesn't like me to touch the screen and have it up. So my lowest point in the height is 0, which by my restriction, that's what it's supposed to be. But also, you can see it on the picture, and it goes forever up. Now, for those of you who might be worried about looking at the graphing calculator and you want to make sure you could do it by hand, you certainly could and put them on the same graph. Right, so I'll do the first one, the y equals x squared. Remember, this is a parabola, and it's moved down 6 spaces, right? You can remember that from your general graph, but we can also do it by points, right? So our x is restricted. It can be equal to 0, but not lower. So we'll do 0, 1, 2, 3, right? And we're going to just plug in. So 0 squared is 0, minus 6 is -6. 1 squared is 1, minus 6 is a -5. 2 squared is 4, minus 6 is a -2. 3 squared is 9, minus 6 is 3. And if I do one more, 4 squared is 16, minus 6 would give us 10. So that one's going to go off the grid, but I can put that on. So over 0 but down 6. 1, 2, 3, 4, 5, 6. 1, -5. 2, -2. 3, 3. And 4, 10. About right there. Sorry about the squiggle. Right, that is our original function. And now we're going to switch and do the inverse function, which is a square root. And remember, the choices we can pick here, your radicand has to be greater than or equal to 0. So x plus 6 has to be greater than or equal to 0. So x has to be greater than or equal to -6. So -6. And then we could pick -5. All right, putting -6 in there, -6 and 6 gives you 0. Square root of 0 is 0. Putting -5, -5 plus 6 gives you 1. Square root of 1 is 1. If I put a -4, it's going to give me square root of 2, not so nice. Let's do a -2. -2 plus 6 gives me 4. Square root of 4 is 2. If I put a 3 in here, 3 plus 6 is 9. Square root of 9 is 3. Right, and now let's graph those. So -6, 0, 1, 2, 3, 4, 5, 6. -5, 1. -2, 2. 3, 3. This point they have in common. Right, and so looks like that. They do flip over the line y equals x, which would be right through here. And notice also here my x's and y's switched. I could have just done that from here, but I wanted to calculate and show you that what I was doing on the calculator was okay. Here we can see them side by side. I'm not real sure why they put this next problem in this section because it does not have a restriction after it. We'll look at it real quick. Maybe that's what they wanted us to see, whether there was a restriction or not. There is no restriction on this one. So they want us to find f inverse. So we'll call this y equals x plus 6 to the third. Switch the x's and y's. X equals y plus 6 to the third. Right. Now we want to isolate the y, so you're going to do a cube root. Doing a cube root does not cause you to have to do plus and minus. Cube root here will cancel the 3. And then you have to subtract your 6. Now be careful here, it's going to be outside your radical. Right. And so that is our f inverse. I'm going to graph this one on the calculator. So we will do y equals, and first we're doing f of x, right? And we will use parentheses, x plus 6. The whole thing is to the third. Enter. And then we will do the cube root of x minus 6. So to get cube root of x, I have to go under the math menu, and I believe there actually is a cube root button. I did not have to put my root in first. Yes, there is. So choose number 4. That is going to be cube root of x. Make sure here that you close your parentheses. That ends the radical. Minus 6. And we'll go ahead and put the graph y equals x so that we can see it flip across. Now, when I hit graph, the first thing it's going to graph is this cube graph. Remember, that one does a curve through 0, 0, and it climbs as it goes to the right. The cube root graph goes sideways. So you'll see these graph in order. It'll do the first one, then the second one, and last it should do the line. So let's watch those. All right, there's your cube root graph. I'm sorry, I said that wrong. This is your cube graph, and notice it slid 6 to the left. That's because it's plus 6 and it's in with the x. They could do the opposite, but otherwise it's your curved cube graph. This is your cube root graph. It slid down 6 because the 6 is out here. It's a vertical movement. This is your line y equals x. It is flipped over. It's a mirror image. Domain and range. And we're supposed to just do that for the inverse function. So the inverse function is this one. Domain, it goes forever to the left, forever to the right. We'll just remember that. I'll write it in a minute because it'll make the calculator go off. Right? And as it goes this way, it gradually goes down, and as it goes this way, it gradually goes up forever. So there is no restriction on the range. So there's no restriction at all on the domain or range of the inverse function, just as there wasn't on the original function. So that's what you expect because the domain and the range just switch. So your domain from here, all reals, becomes your range for your inverse function, and your range here becomes your domain of the other one.
Let's have a look at one more. So we have f of x equals x minus 12 squared, and it has a restriction. This is a parabola. It's something squared. Y equals something squared. That's a parabola. So they're restricting in here. That will only give us half the parabola. So let's see if we can find the inverse. So we have y equals x minus 12 squared. And so we'll switch the x's and y's. Right, to get the exponent off, we have to take the square root, and you get plus and minus. And now to isolate the y, you're going to have to add a 12. I'm going to put it in front of the plus and minus. So this would not be a function. We have to have a look here, and because it has the plus and minus, and this says our y has to be less than or equal to 12. And so here, if we add a square root of x, and so this would be something positive, that's going to be bigger than 12. And so we're going to have to go with the minus on this one. So we're going to have to do 12 minus the square root of x equals y. And this will be our f inverse. And we'll look at those on the graphing calculator. So we'll enter these into our graphing calculator. We'll go under y equals. And we will use parentheses because we want that whole thing squared. X minus 12, parentheses, squared. It has a condition, so use your divide. And remember, put the condition in parentheses. So I have x. I want to get under my test menu. Less than or equal to, which will be number 6. 12. Close that parentheses. And we'll go ahead and put the next one. Our inverse function is 12 minus square root of x. Close your parentheses, and I'll put the line y equals x. We may have to switch our window here. We'll just look and see. Yep, I'm going to have to switch the window. So I would like to see more to the right. on this picture and even maybe more up here. So I'm going to go into my window and I'm going to say, okay, we can let that x stay at -10, but let's go out to max. Let's go to 30. And we'll do the same on the y's. Let's see if that gives us a better picture. Yes. So that's something that your window does. You can see we have moved it out. So there is a picture of our graph. If you need to do it by hand and you've already done this, you can go to your table here to get values, or you can just do them by hand. I'm going to go ahead and pull the domain and the range off of our picture and with our restrictions. So first, for the function, x has to be less than or equal to 12. So it's coming from, and this function is our f of x. All right. So half of a parabola. And so our x value, this right here, this 12, is as high as it can go, but it can go forever to the left. So it's coming from -infinity to the 12, right? The range on it, this 0, that's as low as it can go, and it goes forever up. For our f inverse function, remember they're going to switch. So your domain of f of x will become this range, and this will become the domain. And let's just kind of check that. So this graph down here, if you can see my mouse, is the f inverse. It's a square root function, and the minus in front of it has made it flip over. And the farthest to the left that it can go is 0. And it can go forever to the right. For the range, that's coming from this restriction. The highest it can go is to 12. As you go out this way, this can go on down. So it actually can come from -infinity up to 12, but 12 is going to be as high up as it can go. Our last problem says use a graphing calculator to graph and then use the graph to determine whether the function has an inverse. So we're going to do this in the graphing calculator. It is a cube root graph, and we are going to use the horizontal line test to see if we think it can have an inverse. All right, so in my graphing calculator, I did set my window back to standard, and you can do that quickly by doing zoom and 6 standard 6, and it gives you back your standard grid. All right, so I'm going to do y equals a cube root. So I have to go under the math menu. Number 4 is a cube root of 2 minus x, close parentheses, and enter and graph. All right, so it is your cube root function. These are never straight across, right? It's slightly changing. So if you try a horizontal line test here, you are going to be able to draw a horizontal line. So it is a one-to-one function, and you will be able to find an inverse.